Hey, Karina. Okay, so we wanted to ask you, do you remember your first chemical engineering course?
Yes, it was chemical processes, and I remember Dr. Serino looked like he worked out a lot, and that his expectations were very different from what we had to offer. So they were his expectations were up here, and we were like down here on the floor. So it was a difficult course.
If I remember correctly.
Okay, so this is a homework problem you should have done. So you have gold coming in and chickens and wine, and then that produces a filter cake. And y'all should all know this from high school. And then this right here is how you get your mole fraction, and that's it. Y'all should know that. So, any questions about this?
I have a question.
You.
Why is the chicken in the numerator?
You should already know that from homework. I'm not going to go over that again. It's right here.
I have a question too. We had that exam 1 about a month ago. Do you know when the grades are going to be posted?
Let me think. It'll probably take a month or two. I'll let you know. I have a lot of important
Hey, Jennifer.
Yeah.
Can you tell us about the hardest professor, or the smartest professor you've had?
The smartest professor, that would be Bala.
Okay. Tell us about a time when you felt so far below his level that it was just.
I would say the first day of class when he gave us our placement test that was easy, that we should all be able to do no problem, and none of us knew how to do hardly any of it. And then the next class period, he told us that we all did horrible and that we should have learned this stuff in kindergarten, and his kindergartner could do this work, and none of us, I don't think, we did so horribly. He said nobody passed, and he never even gave it back to us.
Okay, here are your results from your placement test from Calculus 2. No one got above a 30. My kindergartner could have done better than this. Here you go. We'll be going over power series today. This is our general formula. We'll be taking a derivative of this.
Who's the most expressive professor, like with his hands?
I guess it's Naveen.
And tell me about, a memorable situation you had with Naveen.
Well, he was talking about, what's it called? The antibody, yeah. He was doing his hand like this, and he was doing 3 fingers. I can't really remember that much, but it said something special about his limbs.
Class, I'm very disappointed. You had a 25 out of a 60 on the test. 35 average. Is that 35? I can't give you the T-score. You gotta do better than this. I need you guys to take the problems home, do them again, give them back to me, and if I like it, I'll give you the T-score. And you'll see it on the blackboard, alright? Alright, let's start today's lecture then. We'll start with proline. So proline has a nitrogen, and it has the ring. So it's all like this. Alright? The glycine, on the other hand, is more free. It's still out there,
Hey, you.
No.
Hey, we had a question for you.
All right.
Who is the most angry professor in the chemical engineering program?
No engineer. The more angry one, of course, is the
Okay, tell me about a situation, an awkward situation that you had with the class with Beklov, right?
Yes, the sneezing thing.
Can you describe it?
Karina, she sneezed in class. Of course, she sneezed 3 times. Then everybody bless her. And is that a social event? No. If anyone say bless you, it's me.
Good morning, folks. How's everybody doing this morning?
Good.
So today in BioPchem, we'll be going over some of the interactions, hydrophobic interactions.
Bless you.
Who said bless you? What is this? Is this a party? Did you say bless you? No. You said bless you?
Yes.
Okay, one person said bless you, and that person's going to be me, okay? Nobody say bless you in this class unless it's me. Understood?
Yes.
Okay, great. Okay, so hydrophobic interactions. Now, that's all I'm going to explain about that. Now, we'll talk about Henderson-Hasselbalch equation. Now, the answer for this problem is going to be here. And then we can derive an equation for Ka here.
I have a question.
Yes.
Is that a gamma or an 8?
Why would that be a gamma?
It looks like a gamma.
Have I been writing gamma at any point during this class? What are you thinking? Tell me, because I don't understand.
So I guess it's an 8.
Okay, yes, it's me.
What is 8?
The answer. Okay, so does anybody have any more questions?
I have a question. Could you explain to me what alpha stands for?
Alpha. No, it's not an alpha. It's X. X. You understand X? X? You know X? 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 No. You got? Okay. Yeah, it's X. So X, 1 minus X is the denominator. And then, what else? Yes, you can ask, if you don't like somebody, you can ask them, how is diffusion, what's the driving force of diffusion in an interview question? If you like the person, they might answer, it's the change in concentration or concentration. And you may say, okay, that's okay. But if you don't like the person, then you'll be Brownian motion. So Brownian motion is the driving force. You understand? So that comes from Gibbs. Okay?
Oh, hello everyone. Welcome to CHE 3467 process control class. This class is ubiquitous in the industry, but just to let you know about the outline of the class, there won't be any quizzes or the class, there is no obligation to attend the class. So guys, this transfer function controls the feedback loop, which is ubiquitous in the industry. So it can be cumbersome, but it's pretty trivial. And
I have a question.
okay,
Can you go over that diagram one more time, please?
this diagram. So this diagram explains the feedback loop to temperature control and level control. So if this here, if you change the loop from here to this control block and do the proportional integral derivative of and maintain the Ziegler-Nicholas function, you will get the feedback loop control in the CSTR time, so that your flow in and flow out will be maintained at constant flow. And this is ubiquitous since the CSTR can be filled up and it can overflow.
Hello everybody. Welcome to Reaction Engineering. So, you're all seniors, right? Huh? Yeah. What's a CSTR? Huh?
Is the moneymaker of the plant?
No. What's a CSTR?
It's where the reaction occurs and
No! I know you guys wouldn't know, because if you knew, you'd be teaching the class. A CSTR is the moneymaker in the plant. I'm trying to pull up the notes from this, for this lecture.
Professor?
Ah?
Did you try moving the mouse? It seems like it's on protected.
Oh, it must be my TAs, they've messed up.
So, everyone's ready for their exam in thermo? Everyone study? It's an easy exam. It's easy. Just remember. 2. Always 2. Okay. Easy exam. Easy. What do y'all think I'm going to write on the board? Yes.
Thermal?
No. Anyone else?
First law?
No.
Temperature?
No. 2? No. But 2. Remember 2. Think. Make sure you think. You have to think. What else am I going to write on the board? No one? Okay. Think. You have to think. Think on the exam. What's the last thing I'm going to write on the board?
Think.
Close. No. Only 2 questions. See what I did? Good luck on the exam, guys. So, what y'all think of the exam?
It was hard.
It was an easy exam. This was easy. A little disappointed. Put the pen to back. A couple of you had some very creative answers. Some of you had heat production of the sun coming from your reactors. And some of you made this much more complicated than it actually was. Why'd you make it so complicated? Let's be real original. First law, second law. That's all you had to do. It was a one-liner. So simple. If you did not study enough, you really need to pick up for exam 2. I need you to put your hand over your hearts. Close your eyes. Ask yourself, did you really study enough for this exam? Truly. Okay, let's do better on exam 2. So, does anyone have any questions? Yes.
Can we discuss the exam?
No, yeah, so what was your question?
Can we discuss like the exam questions?
See me after class. So, Team 3, how's it going? Good. You have a PFD already?
Yeah, well, we have like something started up. We wanted to actually ask you a few questions about, what we're doing. Is that okay?
Yeah. What questions do you have?
Well, the reactor, we're thinking about using PFR. Would that be fine?
Why do you make it so complicated?
Well, I mean, would you recommend not using a PFR?
Well, you want to do what's more correct. But don't overcomplicate it. Don't make your life difficult.
What about the CO2 emissions? We're a little off spec, and so is it okay for us to use the MEA?
What do you think? Do you want to use it in MEA?
In order to meet specs, I think it would be good.
It's an option. You definitely need to meet spec. But is it worth using it in MEA?
Okay.
Thank you.
No problem. So, I graded your midterms. How do you think you did? You don't know? No idea at all? Maybe D? Hey? B? Maybe? How much time did you spend on the project? As a group?
About 3,000 hours each, so about 9,000 hours total
Total or per week?
per month.
Okay. A couple groups did a little more, but you're doing okay. You can have a report back. Let's go over some issues with the PFD you should probably look at for the final. Overall, it's pretty good. Your reactors here, I noticed you're not using PFRs. You might want to look at substituting a PFR here and make it a little more realistic. It would be a better scenario for your final. And up here, I'm not sure about your product specifications here. As you can see, your CO2, it's a little high. You're just meeting spec, but it's still a little high. You might want to look at maybe a CO2 recovery unit.
Like an MEA?
Yeah, you could use an MEA.
Okay.
Your CapEx is going to be higher, but you could use an MEA. But overall, it's a pretty good design. It has some room for improvement. You might also want to look at some more heat integration. You definitely have some heat waste in here. But overall, you did pretty good. You actually have A-. Any questions? Or are you ready to move on for the final? You have some improvements to make, but don't spend too long on it. Focus on the economics for the second.
So use the PFR.
Well, you can think about using a PFI. It'd be more realistic.
Thank you.
Thank you.
Mr. W.
Yes, Jesse. How many times do I have to tell you? It's Worstel.
My bad, Mr. Snow.
This looks like a good color. Looks like it's about 95% humidity, but it's not gonna work. This will not fly in industry. It might get you an A in this class, but it will not work.
Man, science glitch. I knew that science wouldn't work.
Jesse, wear your safety goggles.
Oh, my bad, Mr. Marshall.
If you keep this up, I'm gonna make you do a presentation.
What? I just done one last week.
Here's your paperback, Jesse. That's good writing. I could read all the way down from top to bottom. But you gotta keep this up, because even though you have an A now, if you keep going like this and you do not improve, it will drop to a C.
Batch, please.
All right, good afternoon, class. I'll be handing back the quizzes that you guys kind of messed up on. So I'll be handing them back in order of favorite to least favorite. And so I'll start with Mr. Brady. And then Mr. Cruz. And everybody else, pick up your exams in the front of the class. So the first problem is the hovercraft. And so we start with the hovercraft. That's a hovercraft. And this one has a small correction where we actually have a jet ski on top of the hovercraft. And what we're looking for is how fast is the water that is bouncing off here and hitting the windshield, how fast is that falling down? So everybody assume that this is all in laminar flow. But that's fundamental error. That's turbulent. That's turbulent. So, but you actually have laminar flow up here, class. Clear?